define your own suspend functions and organize your code in such a way that all the places, all the points of the code that can be suspended are marked with this suspend modifier. So yeah, there is the first question, whether you can define your suspend functions, and yes, you can. And let's look at an example, the other one, the new one. And this example represents just a simple consecutive logic. So say we have like 3 operations we can log in, just load some user identifier, then we can, as a separate operation, load user data, and at the last operation we can show this data. And when you write this code in a straightforward manner, like first get user ID, then get user data, and at last show data, you have 2 points where your computation can be, like if you do it with threads, can be blocked, something that can have time. We can imagine that it does some network requests and the connection can be not good, etc., etc. So they are marked. So yes, you have 2 points that can cause some problems. The first way is to rewrite this code. So yes, now we want it better. We want to avoid this blocking. And the first approach is to rewrite this code with async and await. To do this, you just, instead of returning user ID and user data from your functions, you refactor it and make them return special deferred type. We saw it before, like async returns deferred, and deferred is another word for completable future, for promise. It's just the synonym, so in essence it does the same. And in your function, you have now, instead of user ID and instead of user data, you have deferred objects, so you have to await for them. After rewriting the code to this one, this works, that's fine. And actually, this is how async await works in C#. So when you code in C#, you always have to define this async, await, this async, and always provide the await for them. However, in Kotlin, you can do even better. Because in Kotlin, you can define your own suspend functions. And that means that you can declare all these functions as suspend functions. So instead of returning deferred, you now return expression directly. And you can declare this show user info also as suspend function. And inside this suspend function, you can just, so this is the code that we saw at the first slide with threads. So this is exactly the code that we have initially. But now it works with suspension. So now instead of blocking the user when the connection is bad, you suspend your computation awaiting when you got your result. So the code looks the same, but it works. And there might be a question again. Where can you call the suspend function? And the answer is that you can call suspend function either inside other suspend functions or inside so-called coroutine builders. And we already saw coroutine builders. Coroutine builders is just it's a formal name for launch and async functions. And their goal is to start a coroutine. And there is one more, unblocking, which actually interacts with the regular blocking world, and unblocking will be the entry point to this coroutines programming. So coroutine builders start a coroutine, and looking a little bit under the hood, we actually use suspend modifier not only to declare suspend functions, but also we mark lambdas as suspend lambdas, and coroutine builder is any function that takes this suspend lambda as a parameter. And in essence, this suspend lambda is what represents a coroutine. So when you start with the coroutine builder, this new coroutine, it's marked as something in a suspend context. You can declare nested coroutines, so you can start a coroutine inside the other coroutine. So in this example, I start this launch first coroutine in the UI thread, and then we have a sink that starts another coroutine inside the first one. And here you see these symbols, this arrow with this symbol, and they represent the suspension points. So you can see them in IntelliJ or RStudio. They mark you directly where your computation might be suspended. So they are placed whenever you call the suspend function. A little bit of implementation details. Actually, when you declare this suspend function, the Kotlin compiler secretly adds an extra parameter, continuation. And in essence, continuation represents a generic callback interface. So in the end, it's still programming with callbacks. However, in this case, they are hidden by the Kotlin compiler. So you can think of it like that. And another internal detail, that coroutine is cheap. It is represented by just one object, and it is compiled to a state machine, and every suspension point represents one of the states. So when your coroutine reaches some suspension point, it is put away, and it's stored in the first state, then you return it, then it reaches the second suspension point, it's put away, it's stored in the second state, etc. Again, in our documentation, you can find the exact example of the bytecode that Kotlin compiler generates for this state. I will leave it to you to find it, because anyway, it doesn't work this slide, because you have to think calmly for some time to observe it and to digest this to understand how it works. But we have it. And I still have some time, a couple more words about interaction between coroutines and regular words. So you now have all your code bases, Java code, some Kotlin code, and how they interop with each other, because Kotlin is about interoperability. So we have to think about interoperability in this case as well. First question for you, how do you think, can you call a suspend function from Java? Because I've already shown you, and the answer is that probably you don't want to call it directly, because to call it you have to provide this continuation parameter. And Kotlin compiler somehow does all the magic, but with Java you have to do it by hand, and it's not the way it intended to be done. So it's possible, but probably not the best idea. However, there is an easy way how to interact with Java. So if you have your suspend function declared in Kotlin, you can just wrap it into some kind of future or promise or deferred and return it to Java. So if you have Java 8, you can wrap it into completable future. If you have for X Java, you can wrap it into single, and afterwards you can use it from Java in this way, in a regular way, working with the completable feature of Java. Another thing, if you are working with some third-party library, and this library provides callback-based API, you can, again, instead of calling it directly, providing the callbacks, you can wrap in the suspend function. This function will use special intrinsic Kotlin function suspend coroutine. I don't want to dive into details of how it's implemented. Again, you can just research it and think about it for a while. But the idea is that it's doable, so it's just a pattern, a template that you can do, and you can work with all these third-party API in a way using these suspend functions. The same can be done with RxJava, so you can similarly wrap it. However, with RxJava, there is a wait function defined, suspended wait extension function defined in the library. So you can just call another wait function on a rectangle or completable future. So, you know, Kotlin has extensions, and with extensions we can provide this very native experience. Like await is not a keyword, it's just a function, so you can really declare this function for all the type of features that you have in your projects, and that will work. I expect this question, so we have like 5 more minutes, and I expect you to ask, like, what about RxJava? So we now want to use RxJava, and how does it correspond with, interacts with coroutines? And I want to illustrate my answer with the same example that we used so far. So we had this code. We rewrote this with suspend function. It looked very similar to the straightforward naive version that you write by hand when you first look at the problem. It can be rewritten with completable features, with a bunch of operators. It can be written with RxJava, with a bunch of operators, and with the callbacks that provide all these operators. And I think that I try to illustrate here is that probably you don't need Rx for all kind of tasks. So there exist tasks like if you strive hard to add a Rx for your application, like if you try to find somewhere where you have to add your Rx, you have to invent this observable, that probably coroutines will suit you better for this case. And in general, it's not the question of whether Rx or coroutines. There are a great amount of tasks where RxJava really solves the problem. It provides you a great way to manipulate observables, to correspond with the changes that happen somewhere. But there are other a really big pile of tasks when you just want some consecutive business logic. And in this case, probably it's more intuitive to use direct style of programming with coroutines. Coroutines won't block your thread, and you can use them directly. And also there is a bunch of tasks where you can probably use both. So you saw already that if you for some reason want to call suspend functions from Java, you can wrap it into a rectangle. Or the other case, if you are writing custom operators for your program for Rx, coroutines allow you to write them in a much easier fashion. In a much simpler way. Again, you can find this into documentation, like how the classic example is written in the coroutines, and it's much more understandable in this case, because you know that with back pressure and others, it's hard to provide your own custom operators for Rx.